Here we are in Maquoketa. Thank you for joining me. And today we're going to be talking a lot about the geology of Maquoketa and its surrounding regions. A lot of this is going to have to do with our first stop, the lime kilns, but don't forget that there's much more that's at play here. Things like the Maquoketa Shale, and we're going to talk about why we don't have more diverse rocks such as marble here in Maquoketa as well. Where's all the granite at? Let's talk about that. So here we are at the Maquoketa lime kilns, otherwise known as the Hurstville lime kilns. And what they would do here, all throughout here, down on these and in this one, is they would coke the limestone, much like what they did to the coal that we got. They would do that with the bituminous coal in order to make an anthracitic coal by burning off some of the impurities. Same would happen with limestone, where some of the best limestone in the state of Iowa comes from, right here, especially after the coking process. This limestone is really what we're going to be focusing on a lot in our discussion, talking about the geology of Maquoketa, as well as eastern Iowa in general, because it really does play a big role given that we don't have any igneous or volcanic activity happening here. So we know that the Silurian exists between the Ordovician and the Devonian, but that might make you wonder, why doesn't Iowa have as much missing time as we did in Colorado? Well, if you think about it, unlike Colorado, Iowa does not have igneous volcanic activity, which makes sense when you consider that we don't have huge chunks of time missing, such as the Mississippian through the Ordovician. It's all right here, laid out for you in Iowa. We can see this because we're not sitting on any crazy plate boundaries that are going to make us go up and then erode us down, just like the mountains do. Instead, I hypothesize that glacial activity is responsible for the missing time, such as eroding the newer layer of rock which resides on eastern Iowa that has been removed, making it able so we're able to see older rock the further east we go in Iowa versus western Iowa. So, as we know, most of Iowa, as well as Maquoketa, was formed with rock underneath these shallow seas that existed throughout Iowa. Now, shallow seas are very important for forming a certain mineral that we're going to call limestone. And the Maquoketa region especially was done so during the Silurian era. According to my research before coming here, we can confirm that all of these, such as the gastropods, the corals, the algae, they're found in Jackson County, which is where I live and breathe. So this area, this Silurian time frame in this short, shallow sea is in which we're going to have a lot of the formations we're going to find on the surface around Maquoketa. Behind me now, just east of Preston, is a limestone quarry. Now, I'm not one to argue that sustaining the earth is something that is absolutely vital and should be considered at every turn. But if you look down, just underneath your feet, just about everything is limestone around these parts. So, when you consider what are the uses that limestone has in our day-to-day use? Well, primarily it's used as a construction material, be it in buildings, be it on roads, or be it on your baseball fields. Additionally, it's used in pigments, and it's used all over the United States, not just where it's found. So, go ahead, eastern Iowa, look down and thank your limestone for its service. Now here we are, simply on the side of the road, 5 minutes before you get to Sebula, Iowa, which is 30 minutes east of where I'm from, Maquoketa. If you'll notice, right behind me, we have some of our bedrock here in the lovely eastern Iowa region. It, of course, being limestone. Now, you may pause and ask yourself, you know, how did this limestone get revealed? Why is it like this? This certainly isn't a dike, although it might look like one. Well, if I were a betting man, which I am not, I would say that this has to do with the fact that we are at the top of a large hill that goes down to Sebula, Iowa, which is Iowa's only island city that runs right along the Mississippi River. So with all of that water that wants to go down, it'll probably take some rock with it. And I bet with glaciers, with rain, with all this melt and water that happened over millions of years, this limestone right here has been carved out. Getting to limestone everywhere else in the state can be pretty easy, honestly. Geologists say that the bedrock layer can range anywhere from just 1 foot all the way down to 400 feet. But on average, it's about 60 feet. So here we are in the Maquoketa Caves, one place where I'm proud to call home. The Maquoketa Caves are actually mostly limestone, and we'll be able to tell that here in just a second for sure. But looking around these caves, you can see the wonderful structures that made them, that being the erosion that takes place going through the limestone. These waters will get into little cracks in the rock, and then what'll happen is over time it'll erode, and take many things out. And as you can see, limestone is also relatively easy to erode. And that's the reason in which you can see we're all the way in the Silurian here, because everything else above it, like the shale and other non-basement rocks, have been eroded, which is why we're seeing all this around here, and it also hasn't been disturbed through igneous activity. So one way that you can tell that this is limestone here at the Maquoketa Caves is because I have a bottle of HCl right here, hydrochloric acid. And in theory, if I were to drip this on the limestone, it would bubble like it is right there, which is releasing the carbon dioxide from the limestone. And that happens because when you're in the shallow seas, you have a lot of minerals that is from calcium carbonate, which is all the shells and stuff from the critters that would live in those shallow seas. So right there's a little bit of proof that we've got carbon in these rocks from the calcium carbonate in the shells. So as you can see, this limestone is very similar to the Maroon Formation that we saw when we were in Colorado. We actually saw caves, but we didn't go into them. John gathered our limestone. This should all seem very familiar because seas go in, seas go out. It's all the same kind of process. Geology is the same pretty much wherever you go, in essence of the science and what makes a rock. But it's all a matter of where you are and what part of that geological feature is important to your surroundings. One amazing thing we learned while in Colorado was that seas come in and seas go out, which mean that the landscape is going to be forever and constantly changing while the seas are coming in and out. For example, we're going to have swamps when the seas are all the way in, and leaving beaches, and beyond those beaches are the swamps. Now I stand upon a bunch of mud, and the reason we're here is because we're going to go ahead and be a little creative and use creative liberties to remember this represents a swamp, because believe it or not, we do have coal that comes from Iowa. The coal isn't as great quality as you've seen in other places such as Colorado, but we do get coal, and that harkens back to the seas coming in, the seas coming out. Beyond beaches, we can have swamps, and swampy areas with all this mud and vegetation, mostly the vegetation, all this organic matter is what's going to let us know that we're going to get coal. Because what is coal? Coal is nothing but a collection of carbon that is using all these trees, all this plant life in order to get us some nice solidified coal once it's down in the ground after millions of years. So here I am along the riverbanks of the Mississippi River. I've stumbled upon this, which happens to be a shale. Actually, again, if I were a betting man, I would say that based on the region that we're in, this is probably the Maquoketa Shale, which, ironically, I haven't found any in Maquoketa because I believe it was named after the river, not so much as the town. But shale is a key part of this sea coming in, sea coming out story, because within the deep seas, in that muddy environment, is where you're gonna find the shale. Now, being transparent here, I'm not 100% sure, just looking around, if this shale is 100% native to the area or whether it was weathered away or brought here, be it through the river or through the railroad. But nonetheless, there is shale in this area, and here's evidence of it, at least in present day. As you can see, along the tree line here, we've got some limestone that's visible. And you might ask yourself again, Zach, there are no plates, there's no crazy volcanic activity here, so how can we see that limestone? Well, if you look at where we are, where we're sitting, we're right on the Mississippi River. So, because of that, you gotta assume there's a ton of erosion, and you can see the level of erosion. Look at how crazy that is. That is at least 100 feet right there. So, another thing you have to consider about the lack of igneous activity is that we have the limestone, so we have one component, and we're really far down, obviously, by tilling the erosion. What's the other component? Is marble. Because marble is what happens to limestone once it's metamorphized. So where's all the marble? Well, since we lack the igneous activity, we don't have the marble. And for those of you eyeballing my shirt this whole time, just remember, if it's alive, it's biology. If it stinks, it's chemistry. If it moves, it's physics. And if it rocks, it's geology. Thanks for watching.